to go over is, remember, tangent, when we did that on the unit circle, was y over x. Yeah, you can. Now, if you remember on your unit circles, when we start at 0 and we go to graph this, tangent at 0 would be 0 over 1, which is 0. We knew that tangent at pi over 4 was what? 1. And at negative pi over 4, it was also negative 1. As tangent approached pi over 2, you had 1 divided by 0. What happens when you divide by 0? You get undefined, which when you graph it, what do you put? You put asymptotes. So what happens with tangent is tangent gets asymptotes. Yes. What happens is tangent has repetitive asymptotes at pi over 2. Pi over 2 intervals, if you will. Because every time that you are vertical on a tangent, whether you're at 90 or 270 or pi over 2 or 3 pi over 2, it becomes an undefined function. Now, depending upon where your multiples wind up, when we start shifting things, those asymptotes may shift as well, because they do. But the generic form of tangent always has this as its curve. Always. It is increasing going from left to right. It goes through the ordered pairs of negative pi over 4, negative 1, 0, 0, pi over 4, and positive 1. That's what tangent does. Okay. It's still a bit of a curve going through. The period for tangent, in this case, is going to be pi. The period is always the distance between your two asymptotes. So your period is pi for the generic form. What's that? Sorry. So tangent repeats every pi. Yeah. So sorry, I didn't label that on here. Yes, this is at negative pi over 4, and this is at negative pi over 2. That's what your generic tangents will always look like. What we're going to change around with here is just your A's and B's, but then eventually H's and K's. Your A's and B's, again, your A values within tangent. Your A value of tangent is kind of like your amplitude again. Your A value here is 1. If your A value was 2, then it would be here at 2. It would just move up. That's all it does. Okay. It just I don't know what you want to say, like it stretches it out a little bit, stretches the noodle, or it widens the noodle. I don't know how you want to put it. Your period for tangent functions, like I said, are a little bit different than what we were working with sines and cosines. Wow, I wasn't even spitting as I dropped it. Your period for tangent is going to be pi divided by b. Oh, excuse me. Is it pi over b? Is it pi over b or 2 pi over b? Oh, 2, yeah, pi over b.
Is it so it's the absolute?
Yes, and that's how it was with sines and cosines as well. The asymptotes, what happens here is this is kind of the weird part of how you figure out your asymptotes. Remember, in our graph, we had 0. Oops. This was negative pi over 2, and this was positive pi over 2. The distance between these two is your period. Going from 0 to pi over 2 is pi over 2. Going from 0 to negative pi over 2 is still pi over 2. Pi pi over 2 plus pi over 2 is?
Pi.
Pi. Because distance is absolute.
Oh.
Okay. That's why they're getting this here. So in order to figure out where your asymptotes go, you take your period and you cut it in half. And that tells you where to place your asymptotes. Mike?
How did you get those other 2 points on the graph?
Think about at pi over 4. 45-degree triangle, your tangent value of 45 is always 1 because your opposite and your adjacent are the same. That's how we got it. Just like we picked easy points with the sines and cosines at our quadrantals, when we're doing with tangent, we deal with them at 45s because they're the easy points. The rest of them are there, we just don't mess with them. Because who wants to plot root 3 over 2? Not me either. I like to plot 1. Because it's easy. Okay? That's what we're looking at here. Tangents are very, I would say super easy. It's just remembering that they have the little weirdnesses with your asymptotes. And notice that once you get your asymptote placed, the 2 points you put in are the halfways between 0 and the asymptote. Okay. And then eventually when we shift them, we're just going to move all those values around. So what we're going to do here is just plot some parent functions, and then just add some agents and k's to it, and everything else works the same. The fractions with tangents tend to be the ones that are the pain, because you've got halves with halves, and they turn out to be a little bit weird, but it's nothing you can't figure it out. Okay. Not so bad so far? Let's do a couple more. There we go. Y equals 3/2 tangent 4x. Like I said earlier, this is going to be kind of like plotting a parent function prior to when we get into our shifts. So we do the same thing. What's our A value? 3/2. So A is 3/2. What's our B value?
4.
So we figure out our period here. Our period is going to be pi over 4. Okay. Excuse me. So we plot it. Pi over 4 is the period. In order to get your asymptotes, is going to be 1/2 times pi over 4. What's 1/2 times pi over 4? Pi over 8. Okay. So my asymptotes are going to be placed at pi over 8 positive and pi over 8 negative, because this is our parent function. It's going to go through the origin. Okay. I know it's going to go through the origin, so I put a negative pi over 8 and positive pi over 8. Now, what I want you to think of, because if I take pi out of the equation here, my period is 1/4. You agree?
Yeah.
1/8 on one side, 1/8 on the other side. That's 2/8, which is 1/4. It works because pi is all in the numerator. It all comes along with it. Okay.
Oh, okay.
It takes a second to see that, because it's weird. Like, wait, how did that 4th become an 8th when we think 8 is bigger than a 4? But remember, we're talking in terms of fractions. The bigger the denominator, generally the smaller the fraction is. Sir?
So your asymptotes are half of your period?
Yes, sir. Okay. So now, when I go through this one, all I have to do is mark in my 2 halfway points on either side. So what's half of an 8th?
16.
16. So my points here are going to be at pi over 16, negative pi over 16. And what was my A value? Is your A value positive or negative? That means I'm increasing going from left to right. So I put a point here and a point here and a la-di-da. That's it.
You only have to do 3 points.
Yeah, because your 4th and 5th point are your asymptotes. If you want to think of it that way.
If it was negative, it would just be.
If you're negative, you're going down and to the right.
Okay.
That's the only difference. Yep. That's the only difference here, guys. Yes, it is.
Do we have to list the points?
Yeah, I'm going to get to that. Just like we did earlier when we were listing these things out, because this would be like our parent function, and eventually we'll shift that left, right, up, and down. Just right amount. So you're at negative pi over 6, pi over 16, excuse me, and negative 3 halves, 0, 0, pi over 16, and 3 halves. Asymptotes are vertical. When you have vertical asymptotes, are they x equal a number or y equals a number? X equals a number. So my asymptotes would be at
X equals 530.
Plus or minus.
You can, in this case, it's fine if you want to write plus or minus pi over 8. That's fine. Be careful when you do your shifting, though. They might not be the same value. You could have pi over 4 and pi, maybe, it depends on the period and whatnot. But if they're the same as plus or minus, if you want to write it as x equals plus minus, that's fine. Okay.
Alright.
You're not throwing things at me yet, so it doesn't seem like it's that bad. Because it's what?
Because you said yeah.
Correct. I know my place. Okay? Let's shift it. Gee, what do you think AGK stand for?
I don't know.
I don't either. I don't know. It is so hard. I can only figure out what it stands for.
I was just about to do that, I swear to God.
It's the H's and K's. It's just your horizontal and vertical shift, guys. Everything. Oh no, Michael is trying to impersonate me.
Where are you?
Well, are you?
So basically what we're going to do here, guys, is take the parent function, which is basically what we just graphed, and move it left or right, up and down. It's the same thing we were okay? It's really the same thing. Remember, if your A value is negative, just go the other direction. And it's pretty straightforward. So, let's do it. There's no K. Give me a number.
2.
4.
2. I don't know what I said.
I want him to raise your hand and he like looks at you like, no. Do you remember?
I didn't raise my hand.
You clearly had your hand up.
No, I was stretching. I was like,
No. And then he looked at you like, no.
Don't remember that. Anyway.
You remember that? No. Yeah, shut up.
I remember that.
Yeah. No.
So let's start this one out. What do you think the first thing is that I'm going to do? Identify. So A is negative 2. I know it's negative, so what direction is this going to have to go? So if you want to do that, just so you remember, why not? You know, doesn't hurt. So that way you don't forget. What's your B value? 1. Good.
Uno.
Okay, bueno. Como se dice period?
period.
Que bueno! I wanted to say, what is your period? Qual es el period?
Tres.
I over there.
I don't know. No hablo.
No say.
Antes de ver.
Dios mío. No es bueno en el matemáticas. Anyway, in this case, your period is going to be what? Pi. So your period is going to be pi. Where will your asymptotes go for the original?
Pi over 2.
Good. So in our original, we know that our asymptotes are going to be at plus or minus pi over 2. X equals. Bless you. Okay. Your H value is what?
Negative pi over 4.
And your K value is
2.
2. All right. Now, yes, sir. We know we're going to have to move everything to the left and up. So I'm just kind of overemphasize my graph. Did you guys start doing that, I'm hoping?
Yeah.
Did that make sense by trying to see where it might go to?
Yeah.
Yeah.
Try to.
I get it.
So we are at pi over 2. negative pi over 2. Suggestion, one of the easiest things to plot on tangent graphs, first, put your asymptotes in. Because your parent, once you know where your asymptotes are going to wind up at, you put your parent function in because it's got to go through the origin. And then you can get your halfway points easier. It's just a little bit easier to work with. I know it's got to go to the origin. My A value was 2, or negative 2, so I know I'm going to have to mark off 2. What's halfway between 0 and pi over 2? On both sides, I'll have plus or minus pi over 4. Now the easy part, plotting it. I know it's working downwards, so it's going to be a negative pi over 2 and positive 2. Did I say pi over 2? Negative pi over 4, excuse me. Positive 2, 0, 0, pi over 4, negative 2. And I died.
Oh, I forgot your dots line. I gotta erase every like so often.
Oh, you just write down right.
Hey, I don't want to.
Okay, I was just trying to save you time, man.
I already did that. Yeah. Annoying.
So as I list out my stuff, I'm going to list out everything that I just put on there from the parent function. I've got both my asymptotes written down. I would suggest writing them separately because you're going to add to it or subtract to it. It might be easier because they're not always going to be plus minus when you shift. You've got all your ordered pairs. So now to the h values, what do you have to do? To your x values.
Subtract pi over 4.
Subtract pi over 4 into the y values you
Add 2.
you add 2. So we have negative pi over 4 minus pi over 4. You get
Negative pi over 2.
very good. So your shift, I'll put a different color here. We wind up at, well, negative 1/4 minus a fourth is 1/2, so it's negative pi over 2. All right, bear with me. 2 plus 2.
4. 7?
Radiohead would say it's 5, but you know, it's a song. 0 minus pi over 4.
What?
Negative pi over 4.
Woo! 0 plus 2.
Well, it can't be 2.
It might be, it could be, it is. Pi over 4 minus pi over 4. 0.
0.0.
Oh, this is just kind of crazy dumb luck that we wind up with some easy values here. And then lastly, you have to shift your asymptotes. So you have negative 1/2 and you subtract a fourth and you're at
Negative
Negative 3.
negative 3/4. Very good. So negative 3 pi over 2.
pi over 4.
And then the next one will be at
Pi over 4.
pi over 4. Good.
Why? What? Wouldn't be 3 pi over 4? Pi over 2.
Is it 3 pi over 2?
One is.
Oh, 3 pi over 4. Yeah, I'm sorry. I thought you were looking at the other one. Yes, sorry.
When we shift, can you like draw a different graph? Because, like,
Wait, why is the asymptote?
Why is what?
Oh, wait, that's not.
Because you just subtract pi.
Yes. What's wrong?
Subtract pi.
Hey, what's wrong?
What are we, how do we, what are we adding the asymptote?
We're moving the asymptotes to the left.
Like, so you do your vertical shift. Are we not vertical?
The horizontal shift. Yeah, so to the asymptotes, you're just subtracting your h value, or adding your h value, whatever it might be.
Okay.
Because asymptotes are, even though they're vertical, if you add or subtract vertically, they don't move, do they?
No.
So you have to shift them.
I don't know why that was so confusing for me.
It's okay. Life is tough sometimes. Waiting. Now, what we have to do is replace our values. I noticed that some of you guys are using 2 different colors on some of your graphs. That's awesome, if you want to do that. If you make the graphs larger, you just put them all in one. I know it may not look the nicest. It's okay, because what you're telling me, by doing all the arithmetic here, you're correct. It's just, can you place it on here? This one isn't going to be bad because, once again, I'm going to start by putting my asymptotes in. Pi over 4. Negative 3 pi over 4, which is here. I go through, my first point will be at 0, 0. My next point was at negative pi over 4 and 2. And my next point will be at negative pi over 2 and
4.
4. And it's okay that it's overlapping the parent function because you're just moving it. And you just draw a solid line. And you're done. Okay?
Wait, oh. Sorry.
It really isn't bad because now that you know the nasty thing that I can do to you is by hiding a b value in a parenthesis. That's about it. The rest of it's pretty easy. Questions? Do one more?
No.
No.
Does it hurt? No, it doesn't hurt. You'll get over it.
I will, but I will be scarred.
I can draw two after.
I will remember.
Well, I guess I don't really have another one. So let's just do these. I don't think I need to do the top ones. Let me check that. Because they kind of break up, because you have to grab parent functions anyway. So, let's see this one. Say what else?
No redundancy.
Yeah, but it's not. No, we had 9. We had 10 last night.
Let's see.
Only 7. I did it 2 way last night.
All right, so we'll do the 845.
How many feet?
We'll just do these.
Oh, okay. One more, I can deal with that.
All right, so this is all in 14.2 because with these problems you have to plot a parent function anyway. All right. Do you see why I don't like to do sines, cosines, and tangents all at the same time?
Yeah, no.
Sines and cosines kind of follow all the same rules. Tangents change up just a little bit, and it's kind of
curveball.
I wouldn't say a curveball. It's just that's a lot to remember in one day. I think by splitting them up, it kind of gives you guys the this isn't that bad. We'll go through any of the questions on any of this stuff tomorrow. We'll still have our quiz on. I don't know if we'll do underwater basket weaving or shoe cobbling. It might be one of those two. You'll find out on Friday.
What about
I'm so good at both.
I don't know.
What about cobbling?
What about cobbling?
Shoe cobbling.
Shoe? Oh.
No, shoe, as in your shoe.
You know how to do the shoe cobbling?
You don't know how to cobble a shoe?
Oh
man, you better find out.
Yeah, we did that yesterday at 8 class.
You might have fallen asleep when we did it. What's that?
No, you say y'all bogus.
I don't know what's so bogus about it.
Yeah, we got
Can I? All right, fine. I'll give you a quiz on hydrodynamics.
Dynamics?
Yeah, I do kind of know that stuff.
Oh, chemistry. I like chemistry.
Really?
Like balance chemical equations.
I thought you had classes.
Oh, yeah.
Not enough.
That's the best part.
I swear I thought you had classes
That
before.
was
Oh, they look good though. They look nice.
7 and
I swear I thought you wore glasses.
and like it was just like took so long.